Hello everyone. Now we're going to go into example 9-13. Okay, so I'll read out the problem statement this one because it's a little bit more complex, and then we'll get into the problem itself. So it says the rod shown in figure 9-15, which looks like the following. It's got something called a clevis, and then we have another rod going through it, and then we have this rod that's going through both of them. There we go. Beautiful. So this rod is going to hold a load of 20,000 pounds. Once again, just as I said several times, just because you see it in both two places does not mean times 2. It's still just 20,000 pounds for our load. The material of which the rod is to be made will be a steel designated by the American Iron and Steel Institute as AISI 1020. Okay, AISI 1020. That one. There we go. The steel has an allowable shear stress of 7,500 psi. Okay, that's going to be important. Given shear stress equals 7,500 psi. Oop, bad handwriting. 7,500 psi. Determine the required diameter and select a diameter to use, assuming bar diameters are available in 1/8-inch increments. Okay, so let's talk about that right now. I need to find the diameter, and they come in 1/8-inch increments. Find D. Now, what this means is whatever diameter we solve for in this, we need to get a bigger diameter than that unless we hit right on the 1/8-inch increment. Otherwise, it will fail. We can't say like, well, this is closer to 1/8 of an inch, but we need, 3/16, because that will fail. It has to be bigger than whatever we solve for. But we don't want to go any more than that first step because we're trying to get it just right on the money. Okay, now let's look at our problem and think. What is the area going to look like when we break this rod? Well, if I draw the rod after being broken, I'm going to have one rod on one side, and I'll have a second rod half on the other side. And the area that's new, my shear area, is the area of both of those circles right there. Both circles. So the area would be equal to 2 times the area of a circle, which is pi over 4 d squared. In this case, I don't actually know what d is. I'm solving for it, so I can just leave my equation just like that. Now let's write out our shear stress equation. So shear stress is equal to our load, which we do know, over the area. And I'm going to go ahead and plug in my little equation. It's going to be equal to the load over 2 times pi over 4 d squared. And then I need to solve for the diameter. So I bring d squared over to one side, and I bring the shear stress over. What I get is, from that step, I get d squared is going to be equal to p, the load, over 2 times pi over 4 times the shear stress. I'll take the square root of both sides to get that the diameter is going to be equal to the square root of the load over 2 times pi over 4 times the shear stress. And then I plug in all of my information. And I get that D is going to be equal to square root of 20,000 over 2 times pi over 4 times 7,500 psi. That one's pounds right there. And what I get is that this is 1.30 inches. Okay, so 1.30 inches. We have to think to ourselves, well, it only is in 1/8-inch increments, so what's the closest 1/8-inch increment rod we can get? Well, if we go up here, we can know that there is 1.25. That's an 1/8-inch increments. That rod is pretty close. And then above that would be, if we add an 1/8 of an inch to this, would be 1.375 inches. So your first thought might be, well, this one is closer.
This is only 0.5 off. The other one is 0.07, or sorry, this is only 0.05 inches off. That one is 0.075 inches off. So we should go with the one that's closer, right? Wrong. I mentioned this earlier. You want this one. This one right here is the correct one. That's supposed to be a little check mark. Because if you chose a smaller diameter, it would fail. Smaller diameter would fail. So you have to choose the larger diameter in this case, which is 1.375 inches. So that is our correct answer. Be very careful about that. Always go bigger if you're trying to find the right diameter or size rod to meet your goal. Otherwise, you might choose one that will fail. So I hope this helped you, and this is the last of our stress examples. You did it. You made it through all of them, all 13 examples. I hope this helped you. If you have any questions, please feel free to contact me. Have a wonderful day.